Question 9 is our implicit differentiation question, and that just requires any y term or factor that is a y, or some expression involving y be treated like a function. And we differentiate it by we differentiate it as normal and then put a y prime on the end of it. That's the best way that I can say it. In this equation, we see that the e to the y is by itself. It's a function by itself. It's not in a fraction. It's not a part of a product. So we differentiate it by itself. But then on the right side of the equation, we see a product. We see x squared as our first function and y as our second function. And so we differentiate that as if it's a product. So we use the product rule. And that's why I have here the first function, the x squared function, identified as f, and its derivative f prime is going to be 2x using the power rule. And then the second function is identified as g, so the y is equal to g, and the derivative of that function is just y prime, because we don't know anything else about it. We know it's a function of x, and so we can't really use any rule to differentiate it. So we just differentiate that so that g prime is equal to y prime. Then, as we always do for the product rule, we arrange these in the f prime g plus f g prime arrangement, and so f prime is 2x, g is y, so this is 2x times y, and that's our first term here. We add that to f g prime. F is x squared, g prime is y prime, so that second term becomes 2xy plus x squared y prime. The e to the y we differentiate we're using the chain rule. E is raised to some function. Y is a function. We treat y as a function. So we differentiate the e to the y as we normally would, leaving this function alone. So derivative of e to the y is e to the y. But then because it's y and not x, we tack a y prime on to the end. Now this is just a matter of solving for y prime. And so to do that, we subtract the x squared y prime term from both sides, and then we factor the y prime out, and when we factor y prime out of ey y prime, that's e to the y. When we factor it out of the negative x squared y prime term, that leaves just negative x squared. And then we divide both sides by this e to the y minus x squared to isolate the y prime. And so now the y prime, which is what we are seeking, is 2xy over e to the y minus x squared.